Hey guys, I'm gonna do some modeling for you. Today you're gonna be doing modeling in class. And we're gonna give you instructions for those models, but I wanna give you a little bit of an example. So, you guys know that at the moment that the Big Bang happened, there was immense heat. And there were all these tiny little particles, smaller than neutrons and protons and electrons, smaller than that. They're called like quarks and leptons and hadrons, things you've never even heard of. So those materials started to kind of bump into one another as things started to cool down. You know about the states of matter that gas molecules are really far apart and that the molecules of a liquid are slightly more close together. So if you had a handful of gas molecules, they're flying all over the place because they're really far apart. Okay, you can't even see these things. Okay, gas molecules, yeah. As we started to cool down, those molecules started to get closer together, and eventually they bonded. So now I have two little pieces together, and we're going to go ahead and pretend that these little pieces today are protons, neutrons, and electrons. So in class, I was telling you guys that a proton on its own is basically hydrogen, because hydrogen is made of one proton with an electron circling around it. If I take that proton and I join it together with one neutron, I now have an isotope of hydrogen called deuterium. If I added another neutron, I now have another isotope of hydrogen called tritium. If I add one more proton, so two protons and two neutrons plus two electrons is helium. Now there's a really weird situation in which helium actually loses one of its neutrons. It's no longer helium, but it's not tritium because it actually has two electrons going around the outside. So this is called helium-3. Then you can go and you can add a whole nother proton in and make it helium-4. This is a little complicated, and you guys will see this as we continue to go on through today's activity. But here's where it gets good, is after we have helium-4 created, I can start adding other things to make completely new elements. So if I add one more proton to helium-4, if I add hydrogen to helium-4, I get lithium. If I take hydrogen-4 and I added deuterium, a proton and a neutron, I now get an isotope of lithium known as lithium-6. If I add another neutron, I get lithium-7. I could also make lithium-7 by taking helium-4 and adding tritium. Now I have lithium-7. All right. To take it one further step, let's say I have a helium-4. There it is. And let's say that I have another helium-4. So let me build one right here. 1, 2, 3, 4. I take my helium-4 and my helium-4 and I put them together, and I now have beryllium-8, another isotope. So these are not the true atoms, okay? These are isotopes. These are versions of the atoms that have additional or lower amounts of neutrons than they're supposed to in their natural state. Why is this not in our natural state? Because these are the result of collisions in outer space. At the beginning of the formation of our universe, only 3 minutes after the Big Bang, we started to create these very unstable versions of these atoms. So unstable that they can't exist like that, and they start breaking apart. And the next thing you know, our universe is completely filled with protons. That's why hydrogen is the most abundant element in the universe. 1, 2, 3, 4, 5, 6. That's a lot.